Hello everyone, welcome to my third video. So yeah, today we are going to see some very interesting topics. I was thinking about making video on Lagrange multi multiplier, but I want to study it in more deep. And the next video we are going to make in the Lagrange multi multiplier. Okay, and today we are going to see thermodynamics, entropy. Yeah, I really give you feel the beauty of and entropy, and why our sun is really important for the life in our earth. And I am also going to talk about the changes from the time to frequency domain, and the introduction to the Fourier series, Fourier transform, and the Laplace transform. So yeah, okay. And in the next video, we will understand the transform in detail, and we will also see the application part. Okay, so let me start with thermodynamics. Yeah, so first of all, why we need to study thermodynamics, and why I choose this topic in our course. We have HSA, high speed aerodynamics. Okay, so in that, as in low speed, the pressure will not changes with the density. Means the change in pressure is so small that it do not changes the density. And but when we are talking about high speed flow, so there is a huge change in pressure, temperature, so the density is also changing. So the air is in the compressible air, or the fluid get compressed. So we have to also make sure that while solving the equations of the flow equations of the flow, we have to consider the density field we do not take density as constant, and we do not solve the energy equation and the flow equations separately as we have done in low speed aerodynamics. Okay, so yeah, so first let me start with the most beautiful equation is the let me start with first law of motions. First law of thermodynamics. I am not going into detail. I am just giving you overview. My the important topic I want to discuss today is entropy. So yeah, first law of thermodynamics. So we know that the change in internal energy of the system is equal to Q plus W. Yes. So means if you change the internal energy of the system. So Roshan, what is internal energy? Any system have some of the particles which is constantly moving, vibrating in the high temperature. So we have to the energy stored in the system in the form of vibration, kinetic energy of the molecules. So we have to use the energy stored. Use the heat transfer, and W is the work done on the system. So let me explain you that the change in internal energy when we go from one state to another state, if the one state to another state, the internal energy changes. Okay, so where does the energy goes? It must be transferred into the heat and the work. Okay, nice. So what means? Okay, let me start the discussion of entropy. So I want to say that from where the entropy concept came, means how this word comes in any of the mind. So it starts with the Carnot heat engine. You must have heard or studied it in your class 12th exam. So in Carnot's heat engine, the Carnot is trying to see the maximum efficiency of the engine. So yeah, that is all about. So there is a system where and this is where is heat transfer allowed. There is a question. This is the only part of the system where the heat transfer is allowed, and they, here is the piston. Okay, here is the piston, and here is the not. Here is the piston, and here is the some flying wheel, and what it is doing that there is some gas here, and here is the hot reservoir. So as we know, we have to first of all we are going to maintain the temperature of this, means the process is isothermal, and means delta U is 0, means the heat which is a transfer do not contribute to change the internal energy of the system. It expand the gas, it applies work on the let's I'm not sure that means the gas is doing work on the piston. Yeah. So as it moves up, the gas expands, and here's the important thing that when we take this out, and when let's say the system is here, it also it expand. So you say how it expand, where the expands of the work come in. So here then the gas uses its internal energy to expand it more. And again, what we do, we in the second step, this is the isothermal process. This is isoentropic process. Again the gas will, again what happen where we are not able to achieve, and the Carnot was not able to achieve the 100% efficiency, because if the engine wants to come under same starting point, the piston have to do some work, and if it is the isothermal process, the heat, the work done by the piston to make sure that the piston will be here, the work is converted into the heat, and we will keep that heat in the cold reservoir, and we store the heat in the cold reservoir, and it is the wastage of the waste of the work. Here, if we take the reversible condition, the whole heat is transferred into the work, and yeah, but the here the some amount of work is required for to come to the piston in the original state. So that's why we write that 2W efficiency. 2W is the amount of heat we give, and the QC, light QC is the amount of heat wastage. Means we cannot use this, and by QW we give. So put 1 minus QC by QW. This is the efficiency of the engine. Okay, and it is the reversible process. Means, okay, so when you then after some time, scientists studying the heat engine, I am not remember the scientist's name, I am sorry, and what he do, he observe, as you know that, okay, let me first tell you the real situation, and the at that time the efficiency came is around 30 to 33%. Ideally, if we take the Carnot heat engine, but the amount of real, the industrial amount of efficiency we get is only 3%. Oh yeah. So as you know that in real life there is some friction, it will release in the surrounding. We never get the full adiabatic container. So what the and the okay, so in irreversible process, the total heat cannot convert into total work. The total heat cannot convert into total work. It is waste in, it is the some amount of heat get wasted, and the wasted amount, so entropy is defined as delta Q by T. So the entropy is the amount of heat waste, yeah, wasted, yeah, amount of heat waste, and it is proportional to the it is directly proportional to the absolute temperature of the system. Okay, so yeah, as delta Q by T, it is defined. So means in the real life, the system delta S always greater than 0. In reversible, delta S is 0 because we are all the heat is converted into the work, but in real situation the delta also greater than 0. So then means some heat is always means we are whatever we do in this earth, the 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 process is reversible, irreversible always. So there is some amount of heat energy get released, that is wastage, is that is not converted into the useful work. So how we are alive means how we get the energy. Okay, so yeah, so the sun in the our solar system give us energy of low entropy. Yes, low entropy means it is in the condensed state, is low entropy states, and the low entropy and the low entropy energy, yeah, heat is in the more condensed state is used by ourselves, and when we do the reversible process, the low entropy energy convert into the high entropy energy, and it transfer back into the space. And so you have a question that from where the sun gets low entropy. So I am not aware of that. Maybe the stars, universe, and yeah, so that is why delta is important, and you have to appreciate that why sun is important for life in the earth. Means it will give the low entropy, high condensed energy, and we will convert it into the high entropy, and the more I forgot the word. Okay, maybe you understand. Okay, let me start with the. Okay, so let me start with time and frequency domain transformation. So how first of all, what is time and domain, and what is frequency domain? Okay, so as we know that this is like, I have to give you an example of spring mass system. Yeah. So let me consider as spring, and we are applying a force F at any strength of at any instant. Means I will make a video on Dirac delta function and how it is so important in modern maths and physics. And yeah, so we are applying the force instantly, and what happens that it will moves like this. No, I'm sorry. So yeah, does it move like this, and as the time moves, this will move like this. So how this concept of frequency came, I am trying to make, I have to study it once, so I know about that how why we need to start to know, why we need convert time domain to because domain. The one important example is that when we use transfer function, I will make the transfer function. So when we use transfer function, and we know that in transfer function, first what is transfer function? Transfer function is the Laplace transform of the impulse response of the direct delta input given to the system. Yeah, I will explain you in another video. Okay, so there is a transfer function, and okay, let me explain you in another video. First, let me speak about it that we need to convert time domain into frequency domain because so in convolution, when we convert a time domain, let me apply this any instant t naught is equal to 0. At t naught it will be like applying a force at t naught, it will convert into frequency like this, and then we add infinite number of points, so we get the input qt, and we have to add all the frequency domain. So for adding the whole time domain, impulse response of the time domain, we are using the convolution theorem. But when we go into the frequency domain, we do not need to use the convolution theorem. Okay, so I will explain this all in the other side on the this. Let me also give you some idea about the Fourier series, Fourier transform, and Laplace transform. So in Fourier series, what is Fourier series? Means any periodic function, we can write any of the periodic function, whether it is a sine wave, it is a square wave, it is a triangular wave, anything. We will write any periodic function as a sum of the sines and the sines where, and we have, and let me write you the expression, any function f of t, which is your periodic function, and write n is equal to minus infinity, say infinity. Okay, Cn, I let me what Cn is, and yeah, the power we are taking 2 pi n t. I am not younger this, so I will make this the video how the Fourier series is converted into the Fourier transform. Is when we take time period tends to infinity, we will take any of the function, whether it is periodic or not, and yeah, and the last thing is the Laplace the transform Laplace transform we use in the real life situation. So in here we have the damping, so the frequency have the a to the power minus beta t expression. So we apply e to the power minus term in the Fourier transform and adjusting, and we will take the amplitude and the phase of the frequency, and we will then get the Laplace transform. I will make video on Laplace transform, Fourier transform, next video on Lagrange multiplier transfer function. As I have exams, I have exams from 17th. So yeah, I will trying to make videos whatever I have learned in whole day. Also make some important videos on the important topic. Also dive data function is so important and so powerful function. Means it is at any instant it goes to infinity, and the area under the curve is 1. Means you are like what happened. Okay. So yeah, that's all about today's video.